This is 5-1, solving systems by graphing. A system of linear equations is basically just two or more linear equations, and they contain two or more variables like x and y in the bottom there. Okay, and then a solution of a system of linear equations is going to be an ordered pair. It's where the two equations meet. So if you look on the graph, let me get my pointer out for you. If you look on the graph here, this 2, 3, that is my solution. So the system of linear equations is more than one equation. So notice that I've graphed two equations on this line, and the solution is going to be the ordered pair. In example 1, the first thing they want us to do here is tell whether that ordered pair is a solution or not. So it's looking at 1, 3, and we're trying to see if that's a solution of the system of equations. So the first thing that I'm going to do here is I'm going to take away my x and my y, just coloring this in with white so that you can see the x is supposed to be the 1, so I'm replacing all of the x's with 1, and the y's are the 3 because every ordered pair goes x, y. So where there is a y, I'm putting the 3. And then I'm just going to calculate this. Well, 2 times 1 in the first equation here, 2 times 1 is 2 plus 3 equals 5. So this first equation is true. In the second equation, negative 2 times 1 is negative 2. Add 3 to that and you're only at 1. So this one is not, doesn't equal 5. It's not true. If one of them is not true, then this is a no. It's not a solution of that system of equations. They would both have to have check marks. They both have to work to be the solution. This is how you'll be checking your work eventually. Okay, and this next one, same idea. Let me get my white pen out. Oops. Let's block out the x and the y. Remember that the x is going to go in the first position, so that'll be 2, and this was an x right here. I'm going to put the y in as negative 1, and now we're going to calculate. Well, in the first one, this negative 2 times negative 1 is actually a positive 2. So this really reads 2 plus 2, which is 4. So that one's correct. And in the bottom equation, we have 6 plus negative 1, and that cannot equal 6. So that one's a no. And so this whole thing is no, it's not a solution of the system of equations. So a lot of these sections in this chapter are going to be solving systems of equations, but they're all with a different method. So we're going to look at solve by graphing first. And to solve by graphing, we're just going to graph both equations and we're going to see where the points meet. The point of intersection is the solution. And then we can check our work as well. So in the first two equations, if we look, both of them, the y is isolated. So step 1 would be to isolate y. Step 2 is then going to be to graph. And just a reminder on graphing, start with the b. Begin with b, which is the y-intercept, and then use the slope to rise and run. So let's take a look at what that looks like. So y is isolated, so my first equation I'll do in blue. It's going to be begin at negative 1 with the y-intercept, so it's on the y-axis, and then my slope is negative 2 over 1, since it's a whole number we put it over 1. That means to go down 2, and 1 is positive, so go to the right 1. Down 2 to the right 1. Makes sense because this slope should be negative, so my line should be a negative line. And it is, it's a negative slope. Okay, let's do this next second equation in red. It says to begin at 5 and rise 1, run 1. And if I continue to do that, I'd be off the graph. So I'm going to go the other way. Down 1, left 1, down 1, left 1. Because the slope was 1, it was a 1x. It's 1 over 1. Which is why I'm doing that. So down 1 over 1, etc. So I need to know where these points, where these lines are actually meeting. So let me go back to that blue. I'm going to do this a little bit better. I'm going to go, because I was going down 2 to the right one, I can go up 2 to the left one, up 2 to the left one. And now we can actually see where these lines should meet if I drew this straighter. Let's highlight that spot in green here. That is my point of intersection. So I need to know what that ordered pair is. The solution is the ordered pair of where they meet. And that met at -2 on the x and 3 on the y. So -2, 3 is my ordered pair. That's my solution. Okay, so let me take a look at my first equation. The y is isolated. So that one's ready to graph. I'd go to -3 on the y-axis, and then my slope is 1 over 3. So up 1 over 3, up 1 over 3. Graph that line. If I want to fill it, I could go down 1 into the left, 3, 1, 2, 3, and down 1 into the left, 3. That way I might be able to see my point of intersection easier. Okay, and here's the problem. This next one, the y is not isolated. Remember, it has to be isolated. So this 2x needs to go to the other side, which means I'd subtract 2x from both sides. Remember, I taught you, you don't have to show that. You can just move it to the other side and remember to make it the opposite sign. So it's y equals -2x plus 4, or 4 minus 2x. I just like to have it in the y equals mx plus b form. I'm going to begin at 4. And then my slope is -2 over 1. So down 2 to the right 1, down 2 to the right 1. And I can see where they're hitting already. That point of intersection where we hit is the solution. So the solution for this is 3 on the x, -2 on the y. So 3, -2 is my solution. Remember, we can actually check this. For anyone that's going for that A on the next test, take a look at this. You plug that solution in. So y equals 1/3 x minus 3. Y equals 1/3 times x, which is 3, minus 3. I forgot to plug in the y. So I'm basically just plugging in the x and the y. So -2, and now I'm going to calculate. -2 equals, well, 1/3 of 3 is 1 minus 3. -2 equals -2. So that's correct, and we can check in the next equation. 2x plus y equals 4. So plug in the x, which was 3, plug in the y, which is -2, and see if this is true. 6 plus -2 equals 4. That's true as well. So you can actually know that you're correct. In the beginning of the year, I told you the word per. A lot of times is where we have a variable, and that's the case in this situation as well. So when I write my equation here, I've got y equals 3x plus the $10, so plus 10. In Video Club B, we've got $15 plus $2 per movie. So that one's going to be y equals 2 because of the per is x plus $15. So now with my two equations, I'm ready to graph. So graph my first line. I begin at 10 and I go up 3 over 1. And up 3 over 1. Okay, for y equals 2x plus 15, I begin at 15, and I can go up 2 over 1, or I can go down 2 to the left 1, down 2 to the left 1. Continue that pattern. Looks like I'm going to have to continue my blue line as well. I just realized I was going the wrong way, but I'm going off the graph, and you can see where I'm intersecting here. The graph isn't big enough here, but as long as you get the idea of how to write the equations, graph, and find the solution.